Welcome to part 7 of One Rule One Page series of exponents. Now till part 6th we have learned all the basic exponents rule like power rule, quotient rule, negative power rule, all the rules. But the powers we used were whole numbers, counting numbers like 2, 3, 4, 5, 6. Now the good part is that the same rules apply to fractional powers also, but before deep diving into it, let's understand how to represent those powers, right? So let's start with a square root sign. Suppose I have a square root sign and some number inside it, let's say 2. When nothing is written inside here, that means the power is 1 by 2. Or say it's written square root of pi. So it is pi to the power 1 over 2. Or let's say it's written a by b square root. So it is a by b raised to the power 1 by 2. So square root sign means second power. Now if some number is written inside the v sign, mark my words, inside the v sign, suppose it is third root of 2. Now 3 is written inside the square root sign, so that means it is 2 to the power 1 third, right? So if it is written, or if it is written like nth root of m, so that means it is m to the power 1 by n. Now sometimes what happens, we mistake it with the multiplied number. This is 3, but this 3 is not inside the v sign and now it's 2. So I will write it as 3 times, now it's not the third root, it is outside as product, 2 to the power 1 by 2, correct? Or if it is written like 5 and then fourth root of 6. Now see it carefully. What is present where? 5 is present as a product. So it will be like this. Then 4 is present inside the v sign. So it's actually the fourth root of a number. And what that number is? That number is 6. So 6 is the number inside the square root sign. 4 is the number inside the v sign, which is the fourth root. So it will be written as 5 times 6 to the power 1 by 4, right? Okay, now let's take a case, different case, like when you have like fifth root of say 32, right? And this will be written as 32 raised to the power 1 by 5, nth root of it. Now 32 is not a prime number, so I'll try to solve it a little bit more if it is possible. Let me check if 32 goes with any base to some power. So okay, 2, 2's are 4, 2's are 8, 2's are 16, 2's are 32. So here 2 is multiplied how many times? 1, 2, 3, 4 and 5. So I can write 32 as 2 to the power 5. And then it is 1 by 5. Now according to rules of exponents, this 5 and 5 will be cancelled and I'll be left with 2 only, right? So we can simplify it sometimes. Sometimes it's possible, sometimes it is not possible. Now let's take some more cases like let's see sixth root of 81, right? Now 81 is, I have to check like which number, if I multiply continuously, keep on multiplying when I reach 81. So let's see, 3, 3's are 9, 3's are 27, 3's are 81. So 3 is multiplied how many times? 1, 2, 3, 4. So 3 to the power 4 and then sixth root. I can also write it like this. If I do not get the prime number in between, so I can also write it like this. So now this will be 3 to the power 4 and then sixth root of it, right? So now it will be 3 to the power 4 times 1 by 6 or 3 to the power 4 by 6 or 3 to the power 2/3 if I convert it into the standard form. Now sometimes in some questions I should know how to write it in this format. So if I just it will be 3 2 times 1/3. So this 1/3 is actually the third root. So it will come inside the V sign and 3 squared. So if you are using these rules in exponents, you must know how to write this form into this form or how to write this form into this form. Correct? Just revise this. Then we will apply rules of exponents into fractional powers, right?